Hello everyone, this is Shreya Rathar of class 10 and today I'm going to teach you some easy tricks and important concepts that you should remember in reflection of light. So before we go into reflection of light, we should know what is light. So light is a form of energy that is needed to see things around us. Light doesn't require a medium to travel. That means that light can travel in vacuum also. It can travel in vacuum also. Now, light is a transverse wave, and the speed of light in air or vacuum is 3 into 10 to the power 8 meter per second. Now, we know what is reflection, right? Reflection is the bouncing back of light to the same medium, right? So there are two laws of reflection. The first law says angle of incidence is always equal to angle of reflection. That is angle I equal to angle R. Here you can see angle I equal to angle R. So basically the first law is saying that the angle of incidence, that is the angle between the normal and the incident ray, is equal to the angle of reflection. That is the angle between the normal and the reflected ray. And the second law says that the incident ray, the normal, and the reflected ray all lie on the same plane. So you can see all of these at the point of intersect incidence all lie on the same plane m dash. So only these two laws you have to remember. Now we know mirrors are of two types, plane mirrors and spherical mirrors. In tent, we specifically only have spherical mirrors. So now spherical mirrors are of two types, concave mirrors and convex mirrors. Concave mirrors are also known as converging mirrors, and convex mirrors is also known as diverging mirror. So this is a diagram of a concave mirror. So you can see here how the incident ray after reflection is converging at a point. That's why it is known as converging mirror. And convex, you can see how it is diverging after reflection. So it is known as diverging mirror. Now, two important things that you have to remember is how do you identify if a mirror is a concave mirror or a convex mirror? So there are two ways. One is with touching and one is without touching. So with touching, you can get to know. So like for concave, it is the reflecting surface is always curved inwards, and for a convex mirror, the reflecting surface is always curved outwards. So sometimes you get confused which is inwards, which is outwards. So a easy trick to remember: see, concave, cave, cave. Go inside a cave, so it is always bent inside, so that you can go inside inwards. Okay, and convex obviously will be the opposite. Okay, and now without touching, how will you know? Just keep the two mirrors in front of your face, very close to your face, and observe the images. So in a concave, you will get a magnified image, and in a convex mirror, you will get a diminished image. Understood? Now let's go to the next thing. Now, how do you remember these object position, image position? It's very confusing. So this is for a concave mirror. So it's a very easy. First thing you just remember, nature of the image is always same. That is real and inverted, except for one case. That is when the object is between P and F. Okay. So now, easy way. See, just see here. Object at infinity, image at focus. And here in the fifth one, object at focus, image at infinity. Isn't it the opposite? So if you learn one, you will know other. So you just have to know the relation is infinity and focus. So at infinity, if the object is at, it will be formed at focus. And if the object is at F, it will be formed at infinity. Same thing here. When you keep it beyond C, the image will always be formed between F and C. And when the same thing, when the object is placed between F and C, your image is formed beyond C. Now, if the object is at C, the image is also formed at C. So very easy. If it's formed at C, then the image is also formed at C. So easy. Now only one case, a very special case where if the object is between P and F, that is very, very close actually, that is less than the focus between P and F, then the image is formed behind the mirror. It forms a virtual image which is behind the mirror. Okay. Now, how do you remember the size of image? So, just easy. Okay, if, how far the object is, that much small the image will be formed. Here, the most is infinity. So, at infinity is very far. That's why the image is formed the smallest. That is highly diminished, like a point size. Now, when it comes a bit nearer, beyond C, it becomes diminished. Then it comes at C, it becomes of the same size. It is formed, easy to remember. See, at C, at C. It's same, right? So whenever it is same size. Easy to remember? Yes. Now, between F and C, that is, it came more closer, right? So it becomes enlarged. More closer, it'll get bigger and bigger, right? So it became enlarged. Now, at F, it becomes highly enlarged. And then when it comes so close, it gets enlarged. I told you, this is a special case. Here it gets enlarged. Okay, so easy, right? Now we go for a convex mirror. Convex mirror, there are only two cases you have to remember. And it's very easy to remember a convex mirror because the image formed is always virtual, erect, and diminished. Always. So it's very easy. So now, if the object is at infinity, image is formed at F. Same thing like concave. But here it is formed behind the mirror. Right? Because here only the the reflected rays appear to be passing through the focus. So easy? Yeah. So, and when the image is anywhere between infinity and the pole, you will always get the image between P and F. Okay, fine. Now, sign convention, very, very important for your numericals. So, we have five measurable physical quantities. That is object distance denoted by U, image distance denoted by V, focal length denoted by F, object height denoted by H1, and image height denoted by H2. Now, for a concave mirror, actually, before I tell you the sign conventions, very easy. If a ray from the object will always go from left to right like this. Okay, left to right. Okay, so now when you measure object distance, image distance, or focal length, anything, any distance, you always measure it from the pole to the required physical quantity. Like if it's from object distance, from the pole to the object, image, pole to the object, focal length, pole to the focus. Okay. So if the focus is here or image is here in the left side of the mirror, it will always be negative. Why? Because here the ray which is coming, if it's going opposite to it, it will go minus. And if it's in the same direction of the ray which is coming from the object, it will be positive for the distance. For the height, this is the principal axis, right? So if the object is above the principal axis, it will take a positive sign. And if the object or image is below the principal axis, the sign will be negative. So for a concave mirror, object distance will always be negative because it will always be placed in the left side. It can't be placed behind the mirror, right? It will always be placed in the front of the mirror. So it will always be negative. Image can be negative or positive because in a concave mirror, both real and virtual images formed. So if it's real, it will be formed this side, right? So it'll be negative. And if it's formed that side, the virtual image, it'll be positive. Now, focal length in a concave mirror is always taken as negative, and the object height is taken as positive. Object height will always be taken as positive because it's always upright. You never keep it inverted. It'll always be kept above the principal axis. You can't keep it below, right? Yeah. And image height, again, according to real or virtual. If it's real, it will be negative because it'll be inverted. And if it's virtual, it'll be erect, so it'll be positive. Fine? Easy? Now, when we go for sign convention for a convex mirror, Very easy to remember. See, you know that object distance will always be negative, right? Always. There's no chance that you can keep it behind the mirror. So it'll be negative. And other all are positive over here. Yeah. Image distance, focal length, object height, image height, everything is positive. So it's very easy to remember. Fine. Now, mirror formula. So what does mirror formula actually say? It just says the relationship between your image distance, object distance, and focal length. So that mirror formula is given by 1 by v plus 1 by u equal to 1 by f. Very easy. So this you use it in numericals, but you with sign convention, you should never forget the sign convention. Otherwise, your whole problem will go wrong. So now let's go to magnification. So magnification is defined as the ratio of the height of the image by height of the object, or the ratio of the image distance to the object distance. Okay. Now you can see here the formula of magnification. Either it is m equal to h2 by h1 or m equal to minus v by u. Okay. And magnification doesn't have any unit. Remember that, doesn't have any unit because it is a ratio. Fine. Now your magnification can take two signs, either positive or negative. It takes positive for a virtual image and negative for a real image. Okay, easy. Now magnification can take three values, either less than 1, equal to 1, or more than 1. So equal to 1 means, you can imagine, equal means same size. Equal to 1 means same size. If the magnification is less than 1, it is a diminished image. So less means, diminished means what? It's always less. So you can remember like that. And magnified what? It is big. So greater than 1. Okay. Now, how do you identify the size and nature of the image from magnification? So many people get confused over here. Okay. So how do you actually do? See, here you have given minus 0.5. So in the previous slide we saw minus means real image, right? And 0.5 what? Less than 1? Less than 1. Yes, it's less than 1. So we take it as diminished image. Now here, this everyone will go wrong. Okay, when they've given m equal to minus 1, they'll be like, okay, minus means real image, and minus 1 is what? Less than 1. So they'll be like, it's a diminished image, but it's same size. So that's why. How do you identify? Basically, when you have to identify the nature and size from the magnification, you'd first just see the sign and then just the value. That's it. So like here they've given minus 1. You just see the sign first. So it's minus. So real image. And then you just see 1. 1 is what? Same size. So you get the answer like that. Here, m equal to plus 3. So plus means what? Virtual image. And 3 is what? Greater than 1. So it'll be a magnified image. Okay. So yes, we're done with this chapter, right? So just one last thing, very important to remember, is f equal, like 2f equal to c. That is twice focal length equal to the radius of curvature, right? So okay, we are done. So hopefully you like this video.